Hello, algebra students. Mr. Laurence here, and we're going to put the brakes on just a little bit. Did you hear them? Those are the brakes. Okay, anyway, we're going to review a couple things really quick, make sure we're getting it down really well. There is rumors of a good-sized test, good-sized quiz, I should say, later this week, and they are true. They are true. We are going to be having a test probably on Thursday. Ezra, did you hear that? Thursday. All right, so it'll actually just be a big quiz. All right, first of all, excuse me, laws of exponents and undistributing. Well, first of all, let's do this multiplication here. The quantity of 5x to the 5x y to the 7 times the quantity of 3x cubed y to the 6th. Well, thanks to the commutative property, I can multiply 5 times 3 first, right? And I'll get 15. And then I can multiply x to the first times x to the third, and I'll get x to the fourth. And then we'll get y to the 7th times y to the 6th, and I will get y to the 13th. Now I did that one for you. That was your freebie. I want you to pause the video and try number 2 and 3 on your own. When you're ready to see my solution, unpause the video. Okay, here comes the answer for number 2. Please make sure you've tried it already. I'm raising all this to the 5th power. So 2 to the 5th. Well, 2 times 2 times 2 times 2 times 2. That'd be 32. Now, x to the 5th raised to the 5th. Well, that's like x to the 5th times 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 x to the 5th, right? So that would be x to the 25th. Yes, it would. There you go. All right, maybe you've discovered the shortcut where if it's a power raised to the power, you can simply multiply, and that'll be y to the 45th, and there you go. All right, number 3, I would rewrite it like this. I would write 40 x to the 7th over y to the 5th, and I'll put that over 60 x to the 4th, y to the 4th. And then I'm going to simplify the 40. I'm going to think about 40 as 2 times 20. I'm going to think about the 60 as 3 times 20. And then my 20s will cancel. So my answer is going to be something like this. A 2 in the numerator, 3 in the denominator. Now I have 7 x's in the numerator, right? Normally I don't like to write all these out. And then I have 4 x's in the denominator. These will cancel, leaving me an x cubed in the numerator. And the y's, there's 4 down here, there's 5 up there. 4 of them are going to cancel, leaving a y in the numerator. And there you go. That is the simplified version of the division problem, or that is your quotient. That's the best you can do. All right, here's some GCFs. Go ahead and pause and see if you can get the GCF. All right, here comes the GCF. All right, let me see here. 28. I'm going to go 1 and 28. Listen to the factors of 28, 2 and 14. 3 doesn't go in. 4 and 7 go in. 5 doesn't go in evenly. 6 doesn't go in evenly. And I'm done at 7. So now to find the GCF, I'm going to do 28. See if it goes into 40 evenly. No, it does not. Does it go in, does 14 go into 40 evenly? Nope. 7? 4 does. 4 is my GCF. The GCF of those two numbers, not the GCH, the GCF. Sorry about that. The GCF of those two numbers is 4. What's the GCF of x to the 7th and x to the 12th? Well, remember, I can think about x to the 7th as this. Oops, sorry. And I can think about it as x to the 6th times x to the 1st, and then x to the 5th times x squared, and then x to the 4th times x cubed, and then there are no other possibilities, right? Well, which one of these factors also is a factor of x to the 12th? Well, they all are, right? But which is the greatest? Wouldn't x to the 7th be the greatest of these factors? Right? That number to the 7th power. And so I could think about x to the 12th as x to the 7th times x to the 5th. So my GCF of those two numbers will be x to the 7th. Why? Because it's a factor of x to the 12th. And it's greater than the other ones, other factors. All right. Go ahead and see if you can get the GCF of this one. You have to get the GCF of 16 and 24, GCF of the variables of the x's and the variables that are y's. Okay, if you haven't done it yet, here comes my solution. Please pause the video. All right, the GCF of 16 and 24 I think is going to be 8. And of x to the 10th and x to the 7th will be x to the 7th, and then a y to the 5th. And there we go. All right. So let's see here. Now I have to undistribute. Why do you suppose we did that GCF stuff first? Because we find the GCF and then we undistribute. So what's the GCF of 25 and 10? Well, I believe it's going to be 5. What's the GCF of x to the 4th and x to the 7th? Well, it's x to the 4th. If you haven't noticed yet, it's always the smaller of the two exponents. 4 is smaller than 7. It's x to the 4th. Okay, the GCF of the y's will be a y squared. So when I undistribute, I'm going to have this 5x to the 4th y squared times the quantity. And here's how I get what goes in my quantity. I divide both of these by the GCF. So I'm going to divide by 5x to the 4th y squared, and I'll divide by 5x to the 4th y squared. And so up here, 25 divided by 5 is going to be 5. X to the 4th cancel. Y to the 12th over y squared will be a y to the 10th. 10 divided by 5 is 2, right? The y squareds cancel. Y to x to the 7th over x to the 4th will be an x cubed. And there you go. Pretty simple stuff. All right, we're going to get some practice with this in class tomorrow. You're going to be working with partners and trying some different situations. Okay, Mr. Laurence signing off. Have a good night, everybody.